Welcome to Redshift Cybersecurity's Mobile Pen Testing Training Series. My name is Antie Broek and I am the Head of Mobile here at Redshift. Our goal with this project is to help develop cybersecurity maturity in the mobile application domain by teaching developers and hackers alike some of the basics behind common programming mistakes, the vulnerabilities it creates, and how an adversary might exploit these vulnerabilities in the wild for their own personal gain. We will also be using Redshift's own intentionally vulnerable Android application for the duration of this series. Here we have our mobile application testing process. We start by node 0, which is our setup, where we will be setting up our testing environment with all of our tools required, as well as our testing application that we will be using for the duration of this series. Next, we have mobile application security controls. This is root and jailbreak detection, certificate pinning, and code orchestration. We will be going through the definitions of each one of them, explaining what they are and how to find them, and then how to bypass them if you ever come across them. Next, we have static code analysis. Here we will search for hard-coded secrets, vulnerable code, and functionality bypasses or weaknesses that we can see in the code. So we will be physically looking at the code with a Java decompiler. Next, we have dynamic code analysis, where we will be intercepting the APIs, performing injection-based attacks such as SQL injection, cross-site scripting. Next, we have application logic bypasses, and searching for the exported content providers, and everything we found in static code analysis, here's where we will try and exploit it. Next, we have insecure data storage and application logs. Now, it is very important before we go on to this step to first play with the application login, mess around with the application dynamic code analysis, because we need the data to be populated within the application files and storages before we can go through them to see if anything was stored sensitively or in clear text. So we will be going through the insecure data storage and application logs, searching for sensitive data stored in clear text in the application files such as shared prefs and the databases, as well as the application logs. Finally, we have Runtime Security, where we will be looking at screenshots allowed in application and recent screenshots allowed. We will also be looking at tap checking and how to test for these things. Now we will be going through the tools that we would need for the duration of this series. First, we have Android Studio that we will be using to create emulators to run in our application. We have JetX, which is a Java decompiler, which we can use to do static code analysis. We have APK tool, which we use to decompile and recompile the application in events that we want to do reverse engineering or change anything. We have Mobile that does some static code analysis and dynamic code analysis, which we only use for the low-hanging fruits and to make sure we have full coverage. Then we have Frida, which is a memory hooking tool, and we have Objection that works with Frida. It basically just makes Frida more user-friendly. So all of the links will be in the caption. Download it and install it, and once you're done, we can move on to step 2. Next, we will be moving on to Redshift's intentionally vulnerable Android application. You can download this application along with the Python server and the SSL pinning application on Redshift's GitHub. The GitHub link will be in the caption. Here we have useful resources that I use on a daily basis when it comes to mobile pen testing. The first one is the mobile Gitbook. This Gitbook is so useful. It has instructions and descriptions of all vulnerabilities and everything that comes to mobile pen testing. The next one is Owasp's mobile checklist, which you can use when you have an assessment to make sure that you've covered all the bases. Now that we've set up an environment with all of the tools and resources that we need, we can move on to our next episode, which will cover mobile application security controls, so root detection, code orchestration, jailbreak detection, and certificate pinning.